Hey guys, so today I'm going to do a quick review over permutations and combinations. So the first thing is permutations, where order matters, and this is a really important fact about permutations, and you'll see it everywhere in textbooks and videos and stuff like that, and it's the main difference between permutations and combinations. So our first problem we have here is how many different ways can you elect a president, vice president, and secretary from a group of 15 people? So what we know from this problem is, what it tells us is that there are 3 positions to be filled and 15 people to choose from to fill these positions. So what we can do with this information is we can figure out how many different ways we can elect these 3 people. So if you think about it, the total number of people you have possible, for example, for president, you could have 15 people, since there are 15 total people, and then 14 people because for the vice president, because you already chose one person, and for the secretary we only have 13 people. And 15 times 14 times 13 equals 2,730. And this is the number of different ways we can elect the president, vice president, and secretary. Now what makes this a permutation is because order matters. So why does order matter? Because president, you can't just say, oh, I have Tom as president and Jerry as, Jerry as VP, and for example, Frank as secretary. You can't just say that, oh, I just have a group of 3 people and Frank could be president and Jerry could be VP and whatever. The order matters because each person has their own designated role. So that's why we have permutations. So the next problem for permutations is how many different zip codes can be generated in California if it must be an even number. So what we know about zip codes, we'll assume that they're 4-digit codes, and so that means they're 4 numbers. Now, if you remember, the condition for a number to be an even number is that the last digit has to be an even number. So the only thing we care about is the last digit. So now we have basically 4 different positions to fill. 1, 2, 3, 4. So for the first one, we don't have, the first 3 actually, we don't have any restrictions because for an even number we only care about the last digit. So how many total digits can we basically generate since there's no restrictions? Well, from 0 to 9, there are 10 numbers. Remember, this is including the 0, so that's why we have 10 numbers instead of 9. And so we have 10 for the first 3, 10 possible choices for the first 3 digits. And I'm going to erase these here. So it would be 10, it would be, actually just write that as 10 to the 3rd, since there are 3 digits. And we multiply this by, so how many, for the last digit we need that to be an even number, since we need our whole zip code to be an even number. So how many even numbers are within 0 to 9? Well, that's basically half. So it would be half would be 5. Half of 10, 10 divided by 2 equals 5. So we have 5 possible numbers we can choose from for the last digit. And when we multiply these together, we get 5,000 possible ways to generate different zip codes if it must be an even number. So the reason why this is a permutation again is because zip codes, for example, 3045 is different from 4053. These are entirely different zip codes. Now the only difference in between these zip codes is the order. They use the same numbers, 3045, 4053. They're just in different orders, which makes them different locations. So here's a picture of the permutation formula. So this is the formula that you're probably going to be using when you're solving problems relating to permutations, and basically it's most commonly in this form. So NPK, N is the size of the set. So in the case of our zip codes here, we don't really have a size, but there are different problems that may have a size. And K is the number selected equals the total permutation, the total size of the set factorial over n minus k factorial, and the n minus k is in parentheses, so you do this first before, you don't distribute the factorial. You subtract n minus k before you do the factorial. So now we're going to talk about combinations where order does not matter. Now remember, in permutations, I told you guys about that order does matter. So again, this does not and does, that's the only difference between permutations and combinations. So I'll get more into that later. So a teacher must choose 3 students from 7 students to hand in homework. How many different ways can she select the students? So the students here is referring to the 3 students. So we're talking about a group of students here. So one individual really doesn't matter from the other. So for example, Tom, Jerry, and Frank are the same as Frank, Jerry, and Tom. These are the same group of people. They're just arranged in different orders. But, you know, order doesn't matter in combinations. So we don't count these as separate. And normally in permutations, we would count these as separate. But we just treat this as one, even though in permutations it isn't. So how many different ways can she select the students? Well, if you think about this, and what I just said about order doesn't matter, we can use the permutation formula actually here, where we have n, which is the total is 7, so 7 factorial divided by n minus k, 7 minus 3 factorial, and this would equal 210 permutations. But remember, we're talking about combinations here. Order does not matter. So the only extra step that we have to take in combinations is that we have to divide by the number of ways we can arrange these 3 students. For example, Tom, Jerry, Frank, Jerry, Tom, etc., etc. So in order to find the number of ways we can arrange 3 students, we do 3 factorial. Because again, for the first student, we have 3 choices to choose from. The second, 2, and the last one, only 1, since there's only 1 student left. So this equals 3 times 2 times 1, which is equal to 6. So we divide this by 6 because this is the number of times that we're double counting the Tom, Jerry, Frank, Jerry, Tom. They're the same people, and we don't need to do that. So 210 divided by 6 is a total of 35 combinations, and that is our answer. So our second question is, there are 25 people auditioning for 5 spots on the varsity softball team. How many different ways can a team of 5 be selected? So we know here that our N, our total number of people, is 25, and our K equals 5 because we have to choose a team of 5 people. So this is a combinations question, as it says here. So we're going to follow the same step we did last time, where we use the permutation formula, and then we divide by the number of ways that it repeats. So this would be 25 factorial divided by n minus k, 25 minus 5, parentheses factorial, and this would equal a very big number, so 6375600 permutations. Now we have to change this into combinations by figuring out how many ways we can arrange these 5 people differently. So for example, Tom, Frank, Jerry, Olivia, and Larry, Jerry, Frank, Olivia, and Tom. Sorry about that. These are basically the same. In permutations, though, we're more than double counting here. We're counting a lot of extra things that we don't want in combinations. So we're going to divide by the number of ways we can arrange 5 people, which is 5 factorial, equals 5 times 4 times 3 times 2 times 1. We don't have to do that. This equals 120, and our permutations divided by 120 would equal a total of 53,130 combinations, and that is our answer. So a helpful tidbit for thinking about combinations problems and how they're different from permutations is that we're usually talking about a group of people in combinations problems. So you can treat that group of people as one whole, like a team of some sort, as in this problem. Whereas in the permutations problem we did with the president, the vice president, and the secretary, those were 3 different positions and they were kind of independent of each other. So basically these 5 spots, they have, you can think of them as like maybe something, they're not unique of each other like the president, vice president and stuff. You're just choosing 5 people. It doesn't matter what order, you're just choosing 5 people. So the combinations formula is C and K, where N is equal to the size of the set and K is number selected. And as you can see here, the combinations formula is basically just an addition to the permutations formula, because the combinations are basically permutations except without those redundancies, because we don't care about order in combinations. So if you look here, n factorial over n minus k factorial, that's seen here, we're just adding an extra k factorial, and this accounts for the number of ways we can rearrange the k and the n so that we don't double count anything. And lastly, I'm going to teach you guys how to use the calculator, which is a TI-84, which is GSMST recommended. So I would recommend that you have a TI-84 because it makes it easier to do everything in class. And so the first step is to click Math, and then you go over to Probability, which is the last thing using the arrow, and you hit either 2 or 3, or you can just scroll down and hit Enter. And one is NPR, which is Permutations and Combinations. And one important thing to remember here is that the way you enter permutations and combinations is you have to enter the N first, and then you have to do your math and stuff like that. And you do NPR, and then you do K, so 3, and then you just get your answer. It's so easy, and it'll help you on your quizzes and tests and stuff like that. So that's all I have today. I hope this helped, and thank you so much for listening.